This pause here allows those inputs from the cortex. Remember, some of these dorsal striatum inputs are from the cortex, the prefrontal cortex. In large part, you can think about these cell types are very similar to the ACC. We talked about the ACC in quite detail. They have very similar roles. These provide a large input to the dorsal striatum because of the conflict monitoring, evaluating risk reward, action selection type of things. The third role here is the sequence and timing. There is so much going on here that just like the thalamus has little assistants like the thalamic reticular nucleus and the subthalamic nucleus, these are kind of like assistants to the thalamus because it's a workhorse. These cells right here are going to be like little assistants to the caudate and the putamen. That is its kind of role here to help direct, because this is what we're doing. The dorsal striatum can be thought of as an orchestra or a conductor to the orchestra. Why? Because that's what these dopamine cells are actually doing up to here. These dopamine cells, be it D1, the excitatory, or D2, the inhibitory, is conducting this go or no go based off of these excitatory or inhibitory neurons. Activation versus inactivation. So these cells will kind of help this, because whenever I said that one projection back up will touch around 1,000 medium spiny neurons, that's it. These cells right here are acting on those medium spiny neurons as well. So it's kind of like an assistant, because you need a lot of traffic control here. This is a heavy, dense, and populated area here. When things are becoming overwhelmed and so forth, these cells can speak back up and help quiet so that they can evaluate, pause, reevaluate, and then proceed. This is a big part of what these cells are doing, and it's very unknown. Why I'm bringing this up with autism, and remember the Parkinson's episode, is because there's a lot of no-go implications. If you think about stereotyping and those just awkward movements, this is a lack of control of this no-go area, because this is inactivating movements. So with things like autism and Parkinson's, there's a lot of uncontrollable movements. It's right here. It's right here with these types of cells and the prototypicals and the substantia nigra pars compacta. So uncontrollable movements will be in large part these, we'll just say the globus pallidus, the external and the internal, because these are GABA as well. Substantia nigra pars reticulata for the GABA, because it's help suppressing the thalamus, and the substantia nigra pars compacta, dopamine, GABA. This is a good reminder right here. This is a pretty good example here that handwriting is very much involved with this. Every action is involved with this. So the uncontrollable movement in large part is just these no-go areas being deficient.